Hello class, this is Miss Cash. I am recording this video here today because I want to show you how to use this tool called Desmos. It is an online grapher. Some of you may have used it before, but I'm always telling people how much I like it, so you should give it a try. So we're going to go to www.desmos.com right up here, and we're going to click Start Graphing. And once we do, we can choose to create an account. And I want everybody to create an account because that's the only way you can save your work. So create an account. You just need to give yourself a name. It doesn't have to be your own name. In fact, I recommend it's not, but some kind of screen name. Keep it school appropriate, of course. And then put your email address in and create a password. Once you've done that, you can click Create an Account and you can start graphing. I'm going to sign in on my account. All right. So then I wanted to show you how you can use this Desmos feature. If you click here and you start typing, if you don't type anything else, it's going to assume it's y equals. So if I type, for instance, x squared, and if I want my little keyboard, it's right down here. I can click Show Keypad and x squared. I get a parabola very quickly because it assumes we're doing a y equals. But if I want it to equal something else, I can also do that. Suppose I wanted a circle. Do you guys remember how we do the formula for a circle? Well, it has to have an x squared and a y squared. So if we did say x squared plus y squared, now it won't graph because it's got to equal something. It assumed it was y and now it's not anymore. So equals, and remember it equals the radius squared. So say I wanted a circle with radius 3, center at the origin because I haven't changed it any. I'm just going to say it equals 9 because radius 3 means I take 3 squared for the equation and it's 9. That would be how I'd get a circle. If I want to say move the circle left or right, do you remember how we do that? We're going to put parentheses around our x. Let's say x minus 3, and when we close parentheses squared, notice that it moved my circle 3 spaces to the right. Suppose I wanted to move it up. I put parentheses around the y value. Y values move it up or down. So I might say y plus 2. And I didn't get a plus sign there. When I close my parentheses squared, notice that it moved that y plus 2 moved the circle down. If I wanted to move it up, I'd come back in here and change it to minus 2. And now it moved it up 2. So play around with that. Move your objects by doing some of the things that we've learned in class, translates or shifts some of our graphs. So what I've asked you to do in this project is come up with a picture that you could make something interesting. It needs to have at least 10 different functions or relations. A circle is not a function, but it is certainly a graph that can make your graph look interesting. So I'm not going to do an entire one here, but suppose I wanted a smile and I decided I wanted my smile to be made up with a parabola. I might just start with x squared, but that's certainly not in the right place. So I want to move it over. So let's make it x. If I want to move it to the right, I'm going to try doing minus 3. Oh, look, it moved it to the right. Very nice. Looks like it could be a smile now, but I notice it just keeps going on and on forever, and I don't want my smile to go forever. I might want it to stop, say, about here. So I have to limit my domain and range, and this is how I'm going to limit my domain and range. I'm going to go in there, and I'm going to find some funny shaped brackets. Actually, they're not there. I'm going to space. I do have to say that y equals to be able to limit my range. I could just limit the domain though. So if I want to do that, I'm going to use the squiggly brackets. They're right next to the P and you have to hit shift. And I want my X between, let's say I want it to stop right here, basically 2, and right here at 4. So I'm going to say 2, oh, wrong place, 2 is less than or equal to x, my x value. See how it cut it off right there at 2? And then I'm going to do another less than or equal to 4. Look at that. My little smile just got cut off exactly where I wanted it to. Now, if I decide, oh, that doesn't look good and I want it bigger, I could always go back and change it to 1 and 5. Now, 1 and 5 might be a little extreme, so I might change it again. But you get the idea that by changing these numbers, I can limit how far my picture goes. And that helps me out a lot because then I don't have to have these functions that go on and on forever. Couple little reminders. If you want a squiggle looking thing, remember that x to the power 3 gives us a squiggle. So if you need something like that, that's really nice. Some other things that we have learned in class, we knew that if we have, say, x to the 4th power things, or maybe something with lots of x's in it, we get more squiggles the more we add. Ooh, boy, that one is a little too squiggly for me. Maybe that. But you can play around with it. Yeah, that may be too squiggly. Another function we haven't looked at it a lot is if y equals the sine of x. And to get that, I think we need to go into the functions. It's a trig function, right? From trigonometry back in geometry. But if I do the sine of x, look at that nice squiggle that I get there. It's what we call a periodic function. If you look at the green one, it goes up and down. It keeps going forever. Really cool. You can shrink it by, remember, how do we make things smaller? We multiply by a number less than 1. Let's multiply by, say, 0.2. You see, it's not quite as squiggly when I do that. If I want it to maybe be shorter waves, I put a 2 in there with the x. And you see how that made it squiggle more often. So play around with changing some of those numbers and seeing things. If you want to change the color, let's say I wanted everything in my picture to be yellow because it's a smiley face. If I click right here and I hold and I click on the yellow color, it has changed my smiley face to yellow. Let's say I want my smile to be black. Click on black. Also, let's suppose I want to fill this area in right here for my smiley face. So I'm going to come up here, and instead of equal to 9, oops, I accidentally turned it off. Instead of equal to 9, I'm going to change that equal to less than or equal to. What's that going to do? It's shaded in my circle. You guys know that when we shade with less than or greater than, that often sometimes will shade in either above or below something. So you can see I've now shaded my circle in with that beautiful yellow because I've done that by putting the less than or equal to sign here. I think that's all the hints and tips I have for you. Now, I want to show you a couple things just so you can get some ideas. There are a lot of things out there when you log into Desmos that you could look at. But trust me, if you go too serious, I'm going to know the difference. So this is something that one of my students did a while back. It's not too awful complicated, but complicated enough that it took them a little while and quite a bit of work. We got some circles there. We've got some slanted lines. I think he used an absolute value function actually for that nose because if you remember, absolute value functions look like V shapes. So he used an absolute value function. He used straight lines. He used circles. The only thing I would like out of this one to make it even better would be to possibly include even more types of functions. Here's the absolute value function he used to get the V for his nose. So just to give you an idea of something along the level of what I'm expecting. I'm not expecting anything super elaborate, but I'm also expecting that you put a little bit of time and a few equations into that work so that I know you worked pretty hard at getting what you want. You can see where he did the squiggle brackets here, right there. Those are what limited a domain or range so that it didn't keep going forever. Play around with those until you get them where you want them. All right, from here, I think everything you need to know is on the worksheet. Be sure you save often. If you make any changes, it will ask you to save. Let's make a quick change here so that we can save it. It will ask you to save. You just click up here to save changes. If you haven't named it, it may ask you for a name, but be sure to save frequently just in case the computer runs out of power or anything like that so that you don't lose the work you have done up till that point. If you have a name for it already, you can just click Save and Done, and then keep working. You can work with up to one other person. If you do, please choose somebody who's going to be here the next time so that you aren't left out in the cold all by yourself. With that, happy drawing. Have a good time. I will be back tomorrow to see your progress, and we'll have good times this week. All right.